Let's say you're a facility manager and you have a building automation system that utilizes the BACnet protocol. You also have utility meters that utilize Modbus protocol. Let's say you currently read your meters manually in the field, writing the numbers down on a clipboard. There is a way that you can integrate the Modbus meters with the building automation system using the Symmetrix EasyMap, also known as the B6030. This one device will allow you to integrate up to 4 Modbus utility meters with your BACnet-based building automation system. Before you connect the EasyMap to the network with the meters, you first need to configure it with an IP address. It's best to put the EasyMap on a network isolated with your PC. The EasyMap comes with a default IP address, 192.168.88.89. So in order to communicate with your computer, you first need to configure your computer to IP address 192.168.88.90 with a subnet mask of 255.255.255.252, as explained in the documentation that comes with the EasyMap. First you connect the power supply to the EasyMap, and then you connect the EasyMap to the network. Now you're ready to configure the EasyMap.
Now I open up a browser and type in the default IP address, 192.168.88.89, and provide the login information. The default login is admin, and the default password is admin. And now I come into the home page. I can go to authorization settings and change my login information through this box, and then click OK if I need to reboot the box, and the box will ask you to confirm the reboot. But for this time I'm going to go in and go to the main page of TCP/IP and BACnet configuration to configure the TCP/IP settings. I type in an IP address of the box. I also type in a matching subnet, mask, and gateway. And there'll be a warning if you don't get the right subnet, mask, and gateway that matches to make sure your default gateway is in your subnet. Then I specify the BACnet UDP port which will be used. This is used in a situation where it is desirable for two groups of BACnet devices to coexist independently on the same IP subnet. The UDP port may be configured locally to a different value to keep certain sets of devices independent from other devices. I can also change the BACnet ID. It's automatically generated from the MAC address. And if you do make a change, make sure that it's unique to the entire network. Here I specify location application description string. It helps the user find the device and the device object name. Next, if I want to enable timid DHCP, I can click the next box. There's a description to the right of what's going on with that. There's also an area below that where you can set the DHCP service as described above to go off in a certain number of seconds. I won't be using this, so I'll uncheck that box. There's also a box for enabling BACnet control objects, and that's a rather detailed level of configuration, again described elsewhere. I won't be needing that. For most monitoring applications, one does not need the BACnet control objects, so I'll be unchecking that area. After I do all the configurations, I click OK. Note that the settings won't take effect until I save and reboot. So I go to the save and reboot area and confirm. Now the box should reboot and come online at the IP address and settings that I've specified. Again, I open up a browser and type in an IP address, which I configured, and log into the box. The next step is to provide information for meters I am going to monitor and choose the templates. For that, I go to the meter configuration page. Here I choose the baud rate, which should match the baud rate of the Modbus RTU meters. The default is 9600 baud. Then I choose the serial mode, which should also match the Modbus serial devices. If you choose to poll Modbus devices periodically, then you need to specify the polling delay, or the idle time in seconds between the end of one poll and the start of the next. And the default is 30 seconds. Now we go to configure each meter. In the drop-down box, we choose a template for the model of meter at hand. If it is a TCP/IP meter, we specify the IP address. If one has a Modbus RTU meter, leave the IP address field blank. Here you specify Modbus ID, and then if you want to poll periodically or demand in the final description. Move to the next meter. You can configure up to 4 meters. Again, choose the model, in this case, and conserve EM6400. Leave the IP address field blank, since it's a serially connected meter, and type Modbus ID in description. For the third meter, we will specify a non-existent TCP/IP meter. Then again choose meter model, IP address, Modbus ID, and the description. Leave the last one blank. Then I click OK, and reboot the box, and re-log in to check my settings. See the reading.
After you've configured your EasyMap with an IP address and meter information, you can then connect it to the network. You connect the EasyMap to a network which may have Modbus TCP meters connected to it, and that way the EasyMap will be able to pick up the information from the Modbus TCP meters. If you have Modbus RTU meters, you can connect the Modbus RTU using RS-485 directly to the back of the EasyMap.
So after the reboot, we'll go into the BACnet object status and check the status of the object for the meters which we have configured. We configured 3 meters, and you can see the values for those meters made available in the object status. Meter number 1, meter 2, and down at the bottom, meter number 3. So, we can also take a look at the error log and statistics. This gives us the count of the number of reboots of the box. Also, we can see timestamps of queries to the target devices, the target meters, and see information about the status of those queries. And the current timestamp at the bottom. Also, we have an option to clear the log. There is a button at the left where we can go to reset the entire device to defaults. If we need to get back to a known factory configuration state. And we have the authorization setting button at the left where we can reset the username and password for accessing the box.